Hey everyone, in this video we're going to sketch the titration curve for this titration that we have worked on previously. So again, a titration curve is going to be a plot of, in this case, PCA against the volume of the titrant, and again this would be your titrant, so milliliters of EDTA. And if you remember, our initial PCA was 3 point something. This was our initial. And we didn't really do anything special to get the PCA. We just took the negative log of that number, and then we started adding EDTA, and then we added enough EDTA such that one extra drop resulted in a big change in PCA. This would be the inflection point of your titration curve. And then we had excess EDTA. So before the equivalence volume, remember, every time we added EDTA, it got consumed. It bound to calcium. So at this point, we had excess calcium in our Erlenmeyer. And if you remember, we did not use the conditional formation constant. We did not use K primed of F. We just had to figure out the excess moles of calcium and divide by the total volume. But at the equivalence point, remember, we've added just enough EDTA to react with all of the calcium, so EDTA is gone and calcium is gone. The solution just contains the complex, so yes, we had to use the conditional formation constant, and this is where we set the calcium concentration equal to the EDTA concentration. If you look back at your calculations, you'll see an x squared in there somewhere. But beyond the equivalence volume, we kept adding EDTA. We had excess EDTA. So yes, we used the conditional formation constant. But here, the calcium ion concentration did not equal the EDTA concentration. There was excess EDTA. So that's just a review of how we did those calculations. Let me ask you this. How would this titration curve look if you had calcium in the burette and EDTA in the Erlenmeyer? How would that look? Well, let's talk about it. On our titration curve, we'll have PCA on the y-axis, and this time the titrant is calcium, right? This is our titrant, so it'll be the volume of calcium. And did you figure out how the curve would look? It would be kind of flipped, wouldn't it? So before the equivalence volume, every time you add calcium, it gets bound. So here you would have excess EDTA, and yes, you would have to use K primed of F, but this again is where calcium would not be equal to the EDTA. Then you would reach the equivalence volume. That is where you've added just enough calcium to bind all of the EDTA. So you would use the conditional formation constant here, but this is where you would say that calcium equals the EDTA, just like it did before. And then finally, beyond the equivalence volume, that's where not only have you added enough calcium to bind all of this EDTA, you've added some excess. And you wouldn't have to use the conditional formation constant. You would just take your excess moles of calcium and divide by the total volume. So we didn't do any calculations on this type of an example. I hope you try one on your own, and thanks for listening.